So the subject of work comes up in topic 5, which is the forces topic, which is in paper 2, but it is also very relevant in the energy topic in paper 1 as well. So I'm going to talk about it in both contexts here. So if I take a block, this wooden block here, or this blue block here, and I want to move it across the table, that involves me using some energy. It involves me transferring some energy. Okay. It also involves me doing work. I'm doing work to move that block. Yeah? And the amount of work that I do is equal to the amount of energy that I transfer to the block. And energy transferred and work done are exactly the same thing in this case. Okay? Okay, so work done is equal to energy transferred. If I move the block, I'm doing work. I'm transferring energy. In this case, I'm transferring energy mechanically into the kinetic energy of the block. And I'm also, if there's friction involved, I'm also transferring energy to the thermal energy stores of the surroundings because of friction between the block and the table. Okay, so I'm transferring energy, I'm doing work. I can figure out the amount of work that I've done by using this equation. Work done is equal to the force that I applied to the block multiplied by the distance it moves. Okay, so the force times the distance that it moves. Force is in newtons, distance is in meters, and energy transferred or work done is in a unit called joules. Okay, if I move that block 1 meter across the table using a 1 Newton force, I've done a joule of work. I've done 1 joule of work in doing so. Now here's another example. Okay, if I take this block of wood and I lift it a certain height off the ground, okay, I'm moving it a certain distance. Okay, in order to move it that distance, I need to do work against gravity. I need to do work against the force of gravity, and so I'm applying a force to do that. Okay, so I'm timesing that force by the distance or the height that it's been lifted, and I will then get my work done in doing so. Okay, so the force that I use to lift it will be equal to its weight. Yeah, so that's the force. That's doing work against the force of gravity. So another good example of doing work would be to talk about a car that's moving, a car with energy in its kinetic energy store. If you want to stop the car, then you have to do work. You have to transfer energy from the kinetic energy store into another store, usually the thermal energy store of the surroundings. You apply braking force, you bring the car to a stop, you are doing work because you are transferring energy out of the kinetic energy store and into the thermal energy store of the brakes and the surroundings. Okay, so that's work done. I will see you in the next video.